A solid sphere of radius r carries a charge q plus q, capital Q plus small q, distributed uniformly over its volume. A very small point like a piece of its mass m gets detached from the bottom of the sphere and falls down vertically under gravity. This piece carries a charge. If it acquires a speed when it has fallen through a vertical height, we have to find v square relationship. So the total energy of the system before and after the small piece of mass falls will be equal. When the small piece is attached to the sphere, the kinetic energy is 0. The potential energy due to the gravity is mg by, since the piece is at a height y from the ground, and the electric potential energy is qba. At point A. At point B, just before the piece touches the ground, the kinetic energy is half mv square, the gravitational potential energy is 0, and the electric potential energy is qvb. So VA is kq by r and VB is kq by r plus y. Since this distance is r plus y, we'll simply rearrange half mv square is equal to minus kq into capital Q into r plus y, upon r plus kq into capital Q by r plus mg. We'll take the base common, and in the numerator we have minus kq into capital Q into r plus kq into capital Q into r plus y. We'll shift 2 by m to the right hand side and expand these brackets. We get v square is equal to 2 by m into minus kq capital Q r plus kq capital Q r plus kq capital Q upon r into r plus y plus mgy. So these terms can, we get v square is equal to 2 by m kq capital Qy upon r into ry plus m. We'll take y common and m common. So v square is equal to 2 pi into q capital Q upon 4 pi e naught into r plus y into m plus. So the correct answer is option 1.